Let's talk about pseudo-hyponatremia, which is a condition where the lab reports out that the patient's sodium concentration is low, indicating hyponatremia, but actually in the patient, the actual serum sodium concentration is normal. One clue to this is that the patient is reported as having hyponatremia, but the serum osmolality is normal, indicating that you may be dealing with this condition of pseudo-hyponatremia. Let's take a quick look at this. I got this picture from an article in New England Journal of Medicine, from an article called Mind the Gap. It's a very good article, and I encourage you to look it up. The picture here is kind of blurry in the screen, but let me walk you through it. Let's assume you have two subjects, subject 1 and subject 2, and we have about 1 ml of plasma from both the subjects. Now, subject 1 has a normal solid phase. Solid phase is where all your solid components of the plasma are packed, like the lipids and proteins and so on. And the water phase is where you have the water with the dissolved electrolytes like sodium. Now, subject 2 turns out as a bigger solid phase. So let's assume this patient has a pathologic condition such as myeloma and therefore has a lot more plasma proteins. So if I take 1 ml of plasma from this patient, you will see then that 1 ml has less of a water phase now compared to our previous subject here. Now, in the lab, they do not directly measure the sodium concentration here and here. If you put a probe in and you're somehow able to measure it directly, you would get the true value that both these patients have normal concentration of sodium. You can kind of see here already from the you can see here from the distribution of these dots here that the concentration in both these patients is the same. But when you have taken a small aliquot of the plasma, obviously because the solid component is much higher, you have therefore taken less of the water component for your testing. What they do in the lab actually is they dilute this down with a diluent like water, for example, which will give them a bigger volume to do their tests on. So let's assume both these patients now have this plasma volume diluted down. Now, since in the beginning you have taken more of the water phase for subject 1, having more suspended sodium particles, when you dilute it down, it's going to give you a different value compared to when you start off with less number of particles total and you dilute it down, you are obviously going to get a reading that says the concentration of sodium here is less. So this is the phenomenon of pseudohyponatremia. The way to get around it is just to order something called whole blood electrolytes, whole blood lights, which will directly measure the concentration here and avoiding the dilution component, which is what leads to the problem in the first place, causing this phenomenon of pseudohyponatremia.